Greetings and welcome to your geometry recording of the week. We are in the last few days of February. We're also in the week 8 folder of assignments. Actually, today is the last day in February, having 28 days, so we're about to jump right into March. Hard to believe. For our warm-up today, I want you to open up your geometry class in Schoology, and I want you to focus on looking at what your current grade is in the class. I want us to take some time to reflect about where we currently are and where you want to be with your grade. So open up your Schoology and go to Geometry and go to the Grades tab, and I want you to write down somewhere in your math notebook your current grade. You will be giving this to me, so I want you to write down your current grade, and then I want you to look to see if you have any missing assignments. And if you do, how many do you have, and what is your plan for getting those submitted? So start thinking about these things. Remember, you can check to see which assignments you're missing. When you look in the Grades tab, there won't be that little green puzzle icon next to the assignments. That little green puzzle icon lets you know that you have submitted an assignment. So if you don't have that, that means it is missing. So go ahead and click pause and find your grade, and then write it down and click play and return back to the recording. So this week, we're going to take the Unit 6 quiz that covers sessions 1 through 4, and then we're going to move on to sessions 5 and 6. And as always, I do have a catch-up date built into that suggested pacing guide for the week. So take advantage of that. Use that day, that catch-up day, to complete any missing assignments that you didn't get, or that you need to complete, or any missing assignments from the week that you didn't get to or maybe needed a little bit more time on. You can also use it to redo low scoring assignments. Remember, I'm only accepting redos at this time from Unit 6. That is the only redos. No more redos from Unit 5 since we've moved on from Unit 5. All right, so I did want to focus more on the stuff you're going to see in session 5 this week. In the past, I've seen that students need a little bit more instruction with session 5, so that's why I'm choosing to focus on session 5 in the recording today. So in session 5, you are going to be looking at how you can figure out the equation of a line of best fit, as well as examining the correlation for the line of best fit. So for example, if we were to plot some points on a line, or not on a line, a coordinate plane I meant, if we were to plot some points on a coordinate plane, such as this, and we wanted to put a line of best fit in, there's a couple different ways that we can do that, and we're going to look at this week. So one way is to just manually take a straight edge and try to get your line as close to as many points as we possibly can. And then once we have this plotted, or our line plotted, then we could find some points on the line. So the line that we just did, we could find a couple points on the line and calculate the equation for our line. So remember, when we're dealing with lines, we're going to have that equation y equals mx plus b. So just a reminder. And when we're given 2 points on a line, we can plug that information in to find our line of best fit. Another way we can find the equation of our line of best fit is by using a graphing calculator and letting it do the work for us. So that, and then based on the equation of our line that we draw in, we can figure out the correlation coefficient. So the correlation is going to tell us how well our line fits with all the points that we've plotted. So sometimes you're going to have a line that closely can fit the points, and other times our line of best fit is just that. It's a line of best fit. We got it as close as we can, but there are a lot of outlying points. So we're going to take a look at that as well this week. So let's do some of this. So using the data below, find the equation of the line of best fit. Predict how many, let's see here. And then we were asked also, sorry, I'm going all over the place. Let's get back to this slide and stick on it. So we've got a table here. This table tells us that the number of months that somebody owns a machine, it's Kate's machine right here. So the number of months that Kate owns a exercise machine, and then, well, it could be, perhaps it is a treadmill. And then the number of hours of exercise per week she's getting on that, let's say, treadmill. So we've got this table that tells us the number of weeks and the numbers of hours of exercise that she's getting on that machine per week. So what we want to do from this table is we want to figure out the equation of the line of best fit. And then from our equation of line of best fit, we can predict how many hours Kate will exercise in the 12th month. Because if we look at the number of months owned on this table, notice that 12 is not on there. So when we have an equation, y equals mx plus b, but it's actually filled in with numbers, then we could, so here on our table, our x variables are going to represent the number of months that Kate owns her exercise machine, and then our y variable is going to be the corresponding numbers of hours of exercise per week. So in this case, x would equal 12. So once we find our equation of line of best fit, we can plug 12 in for x. But first, we need to find that that equation of the line of best fit. So let's go ahead and do that. So we've got now a nice coordinate plane, and I'm going to start plotting the points here. So remember, our numbers of months will be our x coordinate, and our numbers of hours will be the y. So I'm going to, this will be the months, and then this axis is going to represent our corresponding hours. So the first entry is going to be in 1 month, there was 8 hours of exercise per week. After the 5th month, there was 4.5. The 7th month, there was 3. So I'm going to keep on plotting these points. The 4th month, there was 6. The 9th month, there was 2 hours. The 14th month, I don't really have. Running out of space there. The 5th month, there was 7. So we've got a double. 11 goes with 4. And 3 goes with 6.5. And then we've got 6 and 4. So what we want to do is we want to draw a line of best fit in. We want to get our line as close to as many points as we can. So I'm going to draw in a line of best fit right now. And everybody's might look a little bit different, and that's okay. All right. So there is my line of best fit. So in order to find now my equation of my line of best fit, so the first thing we want to do is plot our points. We've already done that. Then we want to draw in our line of best fit, and now we need to find 2 points on our line of best fit so that we can find the equation on line of best fit. So I want to find 2 points, and the points that I'm going to use have definite coordinates. So I want to find like when they're in the corner of one of our squares, because that's going to give us the best, most accurate, instead of, if you want, you can use really any point, but I want to find, I'm going to use that have actual whole numbers instead of decimals. But you can use any point and estimate where it is. Like this point right here might be at 9.5 and 3 for the coordinate. But any 2 points, so I'm going to go back to my original ones, and let's write down what those coordinates are at those points. So I'm going to go to a different color just so that we can. So this coordinate right here has, this point has coordinates 4, 7. So that point is at 4, 7. That's the coordinates of that point. And then this point down here is at coordinates 11, 2. So we've got 2 points. And remember, once we have 2 points, now this is some good algebra review. Once we have 2 points, we can find the equation of the line that passes through the point 4, 7 and 11, 2. So this is stuff that you want to write down. You're going to be doing this week yourself. So the first thing that we can do is we can find the slope, right? So remember, slope, to find slope, you're going to subtract your change in your y's. So y2 minus your y1 coordinate over your second x coordinate minus your first second x coordinate minus your first x coordinate. So remember, this would be like our x1, our y1. This would be our x2 because it's our second coordinate. So the second y coordinate. So we're going to plug in our second y coordinate, which is 2, and subtract from it our first y coordinate, which was 7, and divide that over put it over our second x coordinate, which was 11, minus our first y coordinate, which was 7. So hold on a second, I made a mistake there. I'm doing my x's, that should have been a 4. So my first x coordinate is this one right here, so that's 4. Let's check our work. Y2 minus y1, x2 minus x1. We got it. So now let's do this, subtract 2 minus 7, and I get negative 5 over 7. So remember, we always leave our slope as a fraction, and our slope is always represented by m. It's always represented by m. So now in our equation for our line of best fit, the equation of a line is always y equals mx plus b. So we found our slope. Do we know our y-intercept? Well, if we look up at our graph here, we can see that our y-intercept looks like it's a little below 10. So either we can use our graph, and I could say that that's at like 9.9 is one way that we can figure out our y-intercept, which is always our b. So b represents, remember, your y-intercept where it crosses your y-axis. Or another way is you could plug, kind of running out of room on this slide, we could plug in, choose one of our variables and plug in y, m, and x, and then solve for b. So that's another way. But because we're running out of space, I'm just going to look at my graph and see that it's about 9.9 for my y-intercept. So I'm going to plug that in. Let's see here. Move this out of the way. So my equation would be y equals negative 5/7 x plus 9.9. That's the equation of our line of best fit. So another way that we could have figured out that, I'm going to go to a new slide here, and let's see, I'm going to hold on a sec. All right, so I did want to show you guys how we can find the y-intercept without using the graph, just to make sure we have a good, accurate y-intercept. So here I've got all of our information. Here are the 2 points that we chose that our line of best fit intersected. We already calculated our slope. And now we need to find our y-intercept. So a way that we can find our y-intercept is to use the information we've gathered so far. So here y equals mx plus b. We know, let's choose one of our coordinates. So I'm just going to go with this coordinate here, and I'm going to plug it in for x and y, the values for the coordinate. So y is 7 equals, I know that my slope is -5/7, and the x coordinate is 4 plus b. So we have one variable that we can solve for. So let's clean up this equation. Let's take -5/7 times 4 over 1. Remember, to multiply fractions, you just go straight across the numerators. -5 times 4 is -20 over 7 plus b. Now to solve for b, we've got -20 over 7, so we need to add 20 over 7 to both sides, plus 20 over 7. So really what we're doing here is we're adding, 7 over 1 plus 20 over 7. So a little bit of work here. Because we've got a fraction, we have to have common denominators to add our fractions. So I'm going to multiply both the numerator and the denominator times 7 so that we can actually add those. So 7 times 7, our numerator becomes 49 over 7, which is the same thing as 7. Now we can add to it that 20 over 7. So 49 plus 20 is 69 over 7. And if we wanted to, we could actually divide that out and see how close our original our original estimation on the graph of our y-intercept. So 69 divided by 7 is actually 9.857, very close to 9.9. So this is we did actually a really good estimation. So then if we wanted to, we could rewrite again our line of best fit as y equals, you always plug in your slope, x, and then we would want to put in our y-intercept. So remember, when we have our line of best fit, you always leave y and x as is. So go ahead and write down this line of best fit that we came up with in your notes. So if you need to click pause to finish taking these notes, please do that now. I'm going to go back to the previous slide. So just remember our steps here. First, we plotted all the points given in the table. We hand drew in our line of best fit. I recommend using a straight edge. We found 2 points on that line. Then once we had our 2 points, the coordinates, we used the coordinates to find our slope. Then we could either, using our line of best fit, do a good job estimating our y-intercept, or do the math that we just did. And then what's cool about, once we find the line of best fit, is we can use that equation now to predict information, such as the question that we asked on the original slide where it said, predict how many hours Kate will exercise in the 12th month. So here is our equation we came up with. So to get our answer of how many hours we can predict Kate to exercise in the 12th month, remember x represents the number of months, so we're going to plug in 12 for x, and we're going to do the math. So here, if you want to just grab a calculator, you can do that. Otherwise, we can do the math by hand. So -5 times 12, we know is 60, so -60 over 7 plus 69 over 7, -60 plus 69, I know is 9, so 9/7. And if I wanted that in a decimal, I would take 9 and divide it by 7, and I'm going to round to 2 decimal places, I would get 1.29. So we could expect her to be exercising 1.29 hours in that 12th month. So that's what's cool about a line of best fit, is that we can use the information to predict future information. All right, so you just learned how to do it by hand, and now we can do this same thing on a calculator, a graphing calculator, and let it do the work for us and see how close our line of best fit is that we drew in by hand is that a graphing calculator can do the work. So if you're using a TI-83 or TI-82, pay close attention to these instructions. So in order to do this, the first thing that you're going to do is look for a stat button on your calculator. So if you've got a TI-82 or 83, look for the stat button on your calculator. It's up near the top of all the buttons. And you're going to click on second stat. So you're going to click on the second key, which is in the upper left-hand corner. Click second stat, and then it gives you the option of L1, L2, L3, L4. So what you're going to do is you're going to click L1, and so I actually just got rid of those directions because these ones are going to work better for you. So find that stat button. Don't worry about clicking the second key. Just find that stat button. Click the stat button, and the first option it's giving you is to edit. Click enter, and then you're going to see L1 and an L2. That's your list 1 and your list 2. So what you'll do then is you're going to enter in your X values right here for the number of months. Your X values you'll enter in for the list 1, L1, and then your Y values you're going to enter in your to the list 2. So go ahead, if you've got this type of calculator, enter that information in, all the X values and the Y values into the L1 and the L2. So if you need some time to do this, go ahead and click pause now so that you can get this into your calculator. Then, once you've got all this information, we're going to calculate the line of best fit. So again, click pause if you need to. So I've entered all my information into my list, and now I'm going to calculate the line of best fit. I'm going to let the calculator do it. So what I'm going to do is I'm going to click on that stat button again. So I'm going to click on that stat button again, and then I'm going to scroll up top to where it says edit, and then the next option is calc. So I'm going to highlight where it says calc, C-A-L-K. And then I'm going to scroll down to the fourth option where it says line REG. So it's a linear regression. It's going to tell us our line of best fit. And then I'm going to click enter, and then I'm going to click enter again. So you will need to click enter twice. And I see that it says, okay, we know the line of best fit is y equals mx plus b. And it tells us that a, and it's giving it to us in the form of y equals ax plus b. And I look at my calculator and I see that a equals negative 0.48. I'm going to round to 2 decimal places. And that b equals 7.76. So now I can use this information, this number, negative 4.8, I'm going to put in where, really, that's our slope. So y equals negative 0.48, because a represents our slope, then I'm going to put x, and now my b is 7.76. So this is my line of best fit that the calculator came up with. Now I also have an r at the value that the calculator is giving me. And it says that the R value is negative 0.86. I'm going to round to 2 decimal places. So this tells us how close our line aligns to all the points of all this given data. If we were to graph it, how close our line gets to all those points. So if your R is close to 1, that means there's a strong positive correlation, that line does a really good job of getting as close to as many points as it possibly can. The closer you are to 0 means that it's not really a good correlation. It's not a good fit. And then if R is close to negative 1, there's a strong negative correlation, which ours really does have. Ours really does have. So I want to compare how close the calculator's line of best fit was to the one that we did by hand. So I'm going to put up the equation. I'm going to do it in green that we came up with by hand. So let me put that down for us so that we can compare it. All right, so our line that we came up with when we did it by hand was y equals negative 5/7, which is the same thing as negative 0.71, plus x plus 69/7, which is the same thing as 9.86. So these are the same line, I just divided out the fraction. So we can see that our equation was kind of close, but they were different. So when you do it by hand, we're not necessarily going to get as accurate as a line of best fit as if we let a computer or a calculator, type of computer is a calculator, if we let our calculator do it. So kind of neat to compare the two. You will look at correlation coefficients this week as well. But that's it. That's what we're going to stop with today, because that's the big thing I wanted to focus on. There is lots of other information about lots of other things you're going to learn in the week 8 assignments, but we're not going to go into that because this recording will get too long. So let me put up your key phrase assignment. So the key phrase assignment this week is we spend time in this recording looking at how we can find the line of the line of best fit of an equation let me say one more time. Okay, so at the beginning of this recording, we looked at taking values from a table, plotting them. We actually plotted them by hand, and then we drew in our line of best fit by hand. And I want you to tell me, what was the slope of that line of best fit that we calculated by hand? So what was the slope of the line of best fit that we calculated by hand? So please make sure you watch this recording because you will need to do this week. And this is going to really help you to be able to do this. So the directions are below if you need a reminder of how to complete the key phrase assignment. Otherwise, have a fantastic rest of your week and let me know if you have any questions.